Hello everyone! In this video, we're going to learn about random number generation, which is really important in computer science. We've already seen one example of where random number generation would really come in handy. When we wrote our Guess My Number game, we had to set our secret number, or our number to guess, to be a value. In my code, I set it to be 4, which means every time the user runs our program and wants to play our game, the number is going to be 4. They're not going to want to play that game very often because there's no replayability to it. Ideally, we'd like that secret number to be randomly assigned to a value that we don't know, we as in the programmer or even we as in the user. And that's where random number generation can really come in and be helpful. Games is just one example. So let's take a look at today's lesson. What we're going to do is open up a new file called randomnumberfun.cpp, and we're going to open up Guess My Number Fun in gedit, because once we learn a little bit about random numbers, we're going to go back to Guess My Number and change that hard-coded 4 to be a random number. So let's go ahead and head over to the VM and get started on these two tasks. All right, we're ready to begin talking about random numbers. In order to generate random numbers, we're going to need to use the rand function. The rand function is in a library called cstandardlib, or cstandardlibrary. So let's head back over to our code and add a pound include for the cstandardlibrary, cstandardlib. Great. Now, with the cstandard library imported, we can use the rand function. We can immediately write code to use the rand function. Let's just use the rand function by calling it. We specify the name of the function and then an open paren, close paren. And we'll put it in a cout statement so we can see what the output is. Wow, that is a really large number. Let's say we run it again, and again, and a few more times. We're always getting the same really large number. Okay, so that's strange. First of all, it's strange that we're getting this really large number. What are we supposed to do with that in terms of our Guess My Number game, where our numbers are supposed to be in the range 1 through 10? Or let's say we're going to code up a dice game like Yahtzee or craps, and we need to generate a random dice roll, which would be the numbers 1 through 6. Or maybe we're coding up a role-playing game and we need numbers 1 through 20, right? How are we supposed to work with this? And if we always get the same number, how useful is that? That kind of brings us back to hard coding a value like 4. So we've got a lot still to learn about random numbers and how the rand function works. So the rand function generates a random number in the range 0 to rand max. And rand max depends on what C++ standard you're using in G++ and what architecture you're using. That would be your actual hardware in your machine, such as is it Intel based, is it 32-bit, is it 64-bit, etc. On our virtual machine, this is what rand max is. That's a really large number. So this kind of makes sense now. We're getting this number, which is in the range 0 through this number. We likely don't want a number that large, so we can limit the range of the random numbers that we get by using a clever little trick. Of course, clever little tricks usually use the mod operator. So if we want a number in the range min value to max value inclusive, we use the mod operator, and we mod the value returned by rand, a really, really big value. We mod it by max value minus min value plus 1 plus min value. So let's say, for example, that we want to generate a random number in the range 1 through 10. So this is our min value, and this is our max value. So we want to assign to a variable called randnum a number in this range. So what do we need to mod rand by? Well, we need to mod it by the max value, which is 10, minus the min value, which is 1, plus 1, plus our min value, which is 1. So 10 minus 1 plus 1 is 10. Any number mod 10 will give us the values 0 through 9, which is n minus 1, where n is the number that you're modding by, 10 in this case. Then if we add 1 to this, we'll get 1 to 10 as our possible ranges of values. So this clever little trick can be used in order to give you a random number in any range that you want. So let's code this up. Okay, I'm running this and I'm always getting 4. Okay, that's not the desired behavior we want, always getting the same number, but at least we've addressed that first problem where we had this really large number and it was not in the range we wanted. Now we have it in the range that we want it, but we're always getting the same number. Before we fix this same number problem, I've got a task to give you. Go ahead and assign to randnum a value in the range, let's say 7 through 10. Go ahead and assign a value to randnum in the range 7 through 10. So randnum will be assigned rand mod. Remember, we'll have our max value minus our min value plus 1 plus our min value. So we could simplify this a little bit if we want. 10 minus 7 is 3, plus 1 is 4. So let's go to the drawing board and see why this works. So any number mod 4 will give you 0 through 3. Then if we add 7 to that range, 0 plus 7 is 7. 3 plus 7 is 10. It will give us a number in the range 7 through 10, which is exactly what we were looking for. So a clever little trick to keep in mind. If you forget the trick, you can always derive it yourself by using your knowledge of modding by any value will give you 0 to n minus 1, where n is the value you modify. So you can always derive this little rule, but it's a clever little trick to keep in mind. All right, so we are now trying to address the problem of getting the same number every time. Well, let me first explain how random number generation works. There's an algorithm that is implemented in the C standard lib library that rand uses. And the algorithm generates random numbers. So let's say I just make up some random numbers here. Okay, so I just made up some random numbers. We know that they're actually much larger than this. But here are some small ones that we can work with. When you run your program and you use rand to get a value, the first value returned in the sequence is always from the same location. So let's call this starting location. If you call rand again later in your program, you'll get the next value in the sequence. If you call rand again later in your program, you'll get the next value in the sequence, and so on and so forth. When your program terminates and you go to run it again, the starting location is the same one as the last time you ran your program. So you'll always get these same numbers, 202, 1, 72, 3, so on and so forth, the more times you call rand. Let me show you this in action. Let's comment out our code that we've written using randnum, and let's just call rand a few times. So these numbers are all different, but every time I run my program, I get the same 5 numbers. So this number here is where the random number generator starts in the sequence to give you a random value. This is the next number in the sequence, this is the next number in the sequence, etc. What we want to do is tell the random number generator not to start at the same spot in the sequence each time. We want it to start at a random position each time. Well, okay, we need a random number to do that. But this is the random number generator, right? It's supposed to be giving us random numbers. Getting a truly random number is actually a difficult problem. But there's something that we can do such that we get a seemingly random number to use as our starting location in our random sequence. That's not really random, but it's going to be different every time we run our program. So this is something kind of interesting. There is something called Unix time. I just clicked on one of the first links when I typed in Unix time into Google, and it's telling me something called the current Unix timestamp. Okay, this is a really large number. This is the number of seconds that has elapsed since January 1st, 1970. That's crazy, right? That was so many years ago. But this is it. This is the number of seconds that have elapsed since January 1st, 1970. If I refresh this page, let's note the last couple digits, 436, 472, 475. This number is continually increasing. It's a really large number. If we could get this number in our program, we could use it in order to tell our random number generator where to start in the random number sequence. This number, theoretically, will be different every time you run your program, unless you run your program so fast that you're running it multiple times within the same second. That's not likely to happen because we're doing this manual sequence. I mean, it could happen. We could be really fast, but it's not something that we necessarily need to worry about because our user is going to play our game, which will take more than 1 second. So we'll use this Unix timestamp, or this Unix time, in order to tell our random number generation what is the starting location in the sequence to start giving us values every time we call rand. So let's go ahead and code up getting this Unix time. We'll need to add another library called ctime. There's a function in the ctime library called time, which will give us the number of seconds that have elapsed since January 1st, 1970. And that function is called time. And we'll put a 0 in here when we call this function. So right here, 152.719958. There we go. They're not exactly matching, of course, because there's been a few seconds that have elapsed since I ran this code and I refreshed this page. But we can get that number, which is really cool if you think about it. Okay, so how do we use this Unix time in association with rand? Well, there's a function called srand in the C standard lib library that seeds the random number generator. And by seed, I mean specifies where to start generating random numbers. And we'll pass it a different value every time we run our program. So let's try it. Put some space in here. Okay, so here are our 5 random numbers here. Note that this is our Unix time. And before, when we'd run this multiple times, we would get the same values. But now we're getting different values. Well, these are the same because the Unix time is the same. But here the Unix time is different, and here the values are different. So if I go too fast, then I will get the same Unix time. There was a 2-second delay. You can see 82 to 84. And we get different numbers. Awesome. We have fixed our 2 strange oddities about working with rand that we initially encountered. So I'm going to go ahead and comment out all of these crazy big numbers and head back to our random numbers in the range 1 through 10. And I'm going to print out a couple of those. And there we have it. Now, when I copied and pasted these pairs of code here, I really should have used a loop, right? Every time we start to copy and paste code, take a step back and think, how could I write this more efficiently? Well, we could use a loop to do this. So that's going to bring me to a task for you to work on. Go ahead and write some code that will print out the results of rolling a 6-sided die 20 times. So think of your standard 6-sided die. So like this guy right here, it has 6 faces. Each face has a number on it, 1, 2, 3, 4, 5, or 6. And we want to roll this dice or this die, 20 different times. Well, we can write code in order to simulate doing that now that we know about rand, srand, and time, and while loops. So go ahead and take a stab at that task and try it. You can do it. All right, so I'm going to have a loop control variable I, and it'll start at 0 and stop at 20. So I need to figure out what I need to mod rand by in order to get the numbers 1 through 6 that simulate the faces of my die. And that would be modding by 6 to get the numbers 0 through 5, and then adding 1 to get the numbers 1 through 6. And I'm going to add a nice label on my output. One thing we mustn't forget, our progress towards our Boolean condition being false. We eventually want I to equal 20, so I less than 20 evaluates to false. All right, here are the results of rolling a 6-sided die 20 times. And those numbers seem to be fairly reasonable. We would expect each number to show up about 1/6 of the time, since it's equal probability that a die face will appear on top when the die is rolled. A last little task here. Start the roll numbers at 1. Right now they're starting at 0, and that might look a little bit strange to a user to see roll numbers starting at 0 and ending at 19. The user would probably expect that they start at 1 and end at 20. So go ahead and see if you can figure out how to change these to start at 1 and end at 20. One way to do this would be changing I to start at 1 and then ending when I is 21, so I less than 21 or I less than or equal to 20. Or just a little shortcut here, we could just add 1 to I right before we print it out. Okay, wonderful. So as promised, we're going to open up Guess My Number Fun and change that hard-coded secret number to truly be a random number in the range 1 through 10. So that's my last task for you this video. Go ahead and adapt Guess My Number Fun to use random number generation. And don't forget all the little things we had to add in terms of libraries in order to get this to work. All right, I've added the cstandard library and the ctime library so I can seed the random number generator and call rand. Before I run this code and play the game, which will truly now be a game, I want to comment on where to put srand. First off, your srand should only be in your program one time, and I recommend putting it as the first executable statement after your variable declarations in main. So right here. That way, there's no risk of ever calling rand before you've seeded the random number generator. You also only want to seed the random number generator one time. The reason why you want to only seed it one time is if you have srands at multiple locations in your code, they may be called within the same second, meaning you're seeding the random number generator multiple times with the same value, but in between those srands, you might be trying to get a value using rand, which means you might be getting the same value from rand multiple times in your program. But it might be kind of hard to debug that because your program may run a little bit faster or a little bit slower depending on essentially how your operating system is scheduling programs. If you have a lot of apps open, then your program may be scheduled less frequently and or for shorter amount of time. Whereas if you have like nothing open and your CPU is sitting pretty idle, then your operating system may schedule your program to run a lot more frequent for longer periods of time, essentially making it complete faster. So just be very careful with your use of srand because it might give you really hard to debug results. To avoid those hard to debug results, just put it only one spot in your entire program and put it right after your variable declarations in main. Think about this kind of like the reserved spot for srand should your program use random number generation. All right, so let's play our Guess My Number game, which is mostly complete at this point. So I do not know what the secret number is. I could put a cout statement right here on line 16 and for debug purposes print out the secret number, but I didn't do that, so I don't know what this number is. So let's start in the middle. 5. 5 is too high, so let's try 2. I guessed it, nice work. So let's run it again, and I'll try 2 to see if it's 2 again, and it's not, it's something different because of srand. All right, let's try 6. Ooh, I'm good. 6, 3, 2, awesome. Let's do one more time. Ooh, it was 10, one of our corner cases. Awesome. So in this video, we started working with random number generation, which we will use a lot in the future, especially when programming games because there's a lot of chance